All right, I think we are live. Hey, everyone. Welcome to the latest edition of the Food AI Collab. I'm your host, Michael Wolf, and today's presentation and talk is titled Using Generative AI to Build Next Generation Flavors and Fragrances. I'm excited to be here with Francisco Clavero and Cindy Sigler, two folks who have been building and helping to build this AI platform for NotCo. At last month's Food AI Summit, Cindy and Francisco unveiled research behind the new platform, and I and the rest of the attendees were fascinated. It was really gripping and enlightening, and we had a great conversation about it. And so I asked them, "Hey, can you come and join us for the Food AI Collab? Do the same thing virtually?" And I was really excited that they said yes. So they're here with us today, and we're going to launch into their presentation, which I hope can be interactive and you guys can ask questions. We'll definitely do most of the questions at the end, but periodically, maybe there's one or two along the way we can jump in. But feel free to drop your questions throughout the presentation, and we could kind of get to them at the end of the presentation. So, um, Francisco, Cindy, thank you so much and welcome. I'm gonna, for the benefit of the attendees, maybe have you guys each introduce yourself. Cindy, can you tell us a little bit about your background?
Yeah, so I'm Cindy Sigler. I got my doctorate in horticulture where I studied floral fragrance biochemistry and interactions with the pollinators and surrounding plants. And after I graduated, I worked at Impossible Foods for 3 years, working with beef flavor. And I have a strong background in analytics, worked with product developers, nutrition and safety, sensory panels. So I knew the whole 9 yards on all the beef with that. And then semi recently, within I guess it was about a year ago now, I started working at NotCo, and I am a senior flavor scientist there, and I'm also part of our technical applications team. So, what that means is taking the tech side, that like on the machine learning side, technology, and helping product developers use that technology for product creation, and as well as I specialize in flavor, so I kind of do some more of the flavor sprint projects as well.
Great. Francisco, tell us a little bit about yourself.
Hey guys, so I'm Francisco Clavero. I have a completely different background. That's one of the magic things about NotCo. So I studied computer engineering and did a master's in artificial intelligence in Universidad de Chile, in Chile. And yeah, I worked in several different industries to start. Worked in finance, worked in a telecom company, at a software factory, but nothing really clicked for me until I got into NotCo. So I've been at the company for about 4.5 years now. Found this perfect mixture of work with purpose and really, really cool AI research. So for the past 2 years, I'd say, I've been working on developing AI models for flavor and just recently fragrance, which is what we're going to talk about. So really, really exciting stuff.
Yeah, I'm excited to hear more. And so you guys have a presentation you're going to present. Like I said, I think it should take, 25, 30 minutes or so, and then we can jump into questions if there are some. But I'll let you guys take it away. Francisco, I think you're up first, or Cindy. I don't know if you guys switched around, but at the Food Day Summit, Francisco went first. So I'll let you guys take it away.
Yeah, of course. And everyone just feel free to interrupt at any moment if you have any questions. So yeah, I guess we can start off with a bit of background on the company. So we started, well, the slide's a little outdated now, over 8 years ago in Santiago, Chile. And really our mission was to try to help solve climate change through revolutionizing the way people eat. So the way we set out to do it was to try to create plant-based alternatives to animal products, but we knew that we needed to make them as close to the real thing in order for people to have no trouble switching at all. So this meant that we not only needed to replicate the entire sensorial experience of a product, but also its functionality. So, for example, in milk, it has a characteristic color and taste, but also you expect it to mix well with your coffee and not break apart. You also expect it to froth and to be able to use it as an ingredient in several different recipes. So This is only possible in the animal product because it has these amazing building blocks. The proteins, starches, and sugars are really, really special. So trying to replicate everything with just plant-based building blocks is trying to solve some of the hardest product development problems out there. And to make things even harder for us, we knew that if we wanted to even get close to accomplishing our mission, we needed to compete in every food category in order to broaden the impact that we had. So we knew from the very early start that we needed to invest into creating cutting edge technology in order to make this rate of innovation possible. So over the years, we have developed products and launched them to market in every food category. Basically, we started out with not mayo, not ice cream. And as we got success cases in launching successful products to market, this got the attention of a lot of investors. We have been able to raise over $430 million to date and reach a valuation of 1.5 billion company. So breaking into unicorn status from Chile. I think it was the second or third Chilean unicorn ever. So it was a pretty big deal. And through this AI technology that we developed, which we call Giuseppe, we have been able to really quickly launch different products to market. Um, and some of the largest brands in the world, like Burger King and Starbucks, have trusted us and helped us get these products to consumers. So we have a really strong brand, especially in Chile and Latin America, and yeah, you can find these products on your supermarket. And over the past year or so, we have built a separate business unit, which B2B business unit, where we have been pioneering getting our technology directly into other CPG companies. So this is really cool because it can allow us to broaden the range of the environmental impact our technology can have. So we can create much more sustainable products and take advantage of the supply chain and the production, the brands of other companies to get more sustainable products to everyone. So we pioneered this with a joint venture with Kraft Heinz, and they trusted us with some of their most iconic products like Oscar Mayer sausages and Kraft singles. And we created that plant-based lineup for them. And we have other partnerships in the pipeline, which I hope we can announce soon. And just recently, we started exploring making our technology available as a SaaS, which was something that some of these companies were really interested in. So, to create a successful technology platform, you have to really focus on your user. You don't build technology just because it's cool, but because it adds value. Creating tech for the sake of tech is just one of the many flaws that software engineers and machine learning engineers like I have. But at NotCo, we really focus on the user. So we have these amazing offices in Santiago and San Francisco, which are really multidisciplinary. Software engineers, AI engineers, product developers, food scientists, designers, chefs, you name it. So we really get together in the office and we can identify pain points that we have in our pipeline. We brainstorm solutions together. And at this step, we do AI research to see what's possible. And we build out really scrappy machine learning models and software systems, just enough to prove that our solution solves the problem. And only once we validate that we're adding value, we go ahead and build a production grade system and integrate it with the rest of our tools. But we don't stop there. So we're constantly monitoring the use of the platform and gathering feedback from our users. So we're constantly evolving the tech, constantly improving, and even sometimes we have deprecated entire applications, entire modules because they weren't up to our standards or weren't adding the value that we hope for. So what this has decanted in over the years is the Giuseppe platform in its current state. It's 4 different web-based applications which are powered by our AI algorithms and systems. And these are backed up by over 20 approved patents. So we have concept generator, formulate OS, synthesis, and a new module, which is the what I've been working on for the past quarters, which is the GenAI Fragances module. So, well, I really love to go through all of them, but yeah, we're going to be focusing on how we apply these modules into building flavor and fragrance into consumer products. So the first approach we had was using an application called Synthesis, and Cindy here is going to tell you all about it.
Thanks, Francisco. Can you go to the next slide, please? So Synthesis is NotCo's experimental design platform used to find optimal formulations in a large space of uncertainty to meet certain outcome objectives. So you choose the raw materials, constraints, restrictions, and Synthesis generates a batch of formulations for you to try. So then I would go to the lab, create these formulas, input them into Synthesis, repeat the process. And what's unique about Synthesis is that it doesn't rely on a large training set because the algorithm learns on the fly, which can discover combinations faster than traditional methods. Next slide. So setting up a synthesis experiment. So first we must define a target. And a lot of times at a plant-based company, it is traditionally like an animal-based target, flavor, texture, or entire experience. And typically the user starts by defining success criteria um, for a project in terms of a finished outcome objective, such as taste, flavor, like I mentioned. And these are outcome objectives. And once we've defined these key attributes, then we need to start selecting raw materials to achieve these objectives in a finished formulation. And these are what we refer to as variables. And a lot of these raw materials need certain guidelines to achieve these objectives in a finished formulation. And this is user imposed conditions to generate formulation. So a lot of times these are like concentration ranges for certain volatile compounds or ingredients that they need to abide by. And once this is all set up, Synthesis generates a batch of formulations, and then those formulations are created and sent for sensory testing. And these feedback scores are then uploaded into Synthesis, which generates a new batch of trials, ideally each round closer to the target. And next slide. So I think it's really important for me to mention hypothesis space when talking about synthesis. So the combinations of all formulations is more than stars visible in the universe, which is completely unmanageable. And this is too large for any algorithm to traverse. So we can set restrictions and parameters to reduce this space. However, even though this space is smaller, it's still too large for traditional trial and error methods. And this is where synthesis comes in. And by constraining elements into this combinational space, by setting restrictions, subsets of ingredients, processes dictated by Komen, domain knowledge, and so on, we can make this space much more manageable and we can work more efficiently in this space. Next slide. So I want to give an example of synthesis in action with an on-site flavor partner. And our target was animal-based cream cheese. And our goal was to identify the key attributes we wanted to optimize for this flavor. And once those outcome objectives we defined are listed on the left, such as creamy, buttery, dairy, cheesy, salty, and so on. And once we identified these attributes, we needed to set the sensory scale that Synthesis would use to take those feedback scores and generate the next batch. So as you can see, we set a scale of 1 to 7, and the ideal target would be at a scale of 4 or at a point of 4. So the outer boundaries are these flavors are significantly less or significantly more than the target. And the sensory evaluation would be conducted by a trained qualitative descriptive analysis panel, and their sensory feedback scores are added so synthesis knows what to look for. And the next slide. So this is basically what the interface looks like once you're setting up an experiment. So the first step is the outcome objectives. And the next slide. So here's an example of setting one up. So one of those attributes or objectives is cheesy. And we wanted to set the score of approximate 4 on that scale of 1 to 7. And we weighted it at a 1. And during this process, we weighted all the objectives the same the weight is of importance. So if we did want to make one of those outcome objectives more important than the others, we might weigh that as a 2 versus a 1. So that attribute might be doubly as important for us to focus on optimizing than something like salty. Yeah. So once we've defined these outcome objectives, the next step is to add these variables, which is creating the hypothesis space, which can allow for a lot of flexibility within the ingredients, such as like flavor keys and flavor compounds. And the flavorists and I, or the company, chose different flavor keys, and we selected the ingredients that they had in-house to fit within these flavor keys. And these are just coded based on their different flavor formulations to describe those keys. And we then set up the constraints, which are the concentration ranges for each of these flavor key sets. And once those are all set up, we generated synthesis generated formulations for us. And we were on site with a flavor partner for 3 days, and we repeated this cycle for over 5 batches. So like I mentioned, synthesis generates formulations. We incorporate those formulations into the plant-based matrix. And then these samples are sent to that QDA panel to analyze for sensory attributes. And those sensory attributes are turned into scores, which are fed back into synthesis to generate the new batches.
So there's a question from
Yes.
in the chat. So Carlos asks, hey, by the way, if this means that we could get flavors that we have never tasted before.
Yeah, so I think with we have a really large ingredient database, and so do some of these flavor houses. So I think we have found really unique combinations through synthesis. Like, for example, our plant-based milk using the cabbage and pineapple and those contain certain volatile compounds that are found in milk, like such as sulfur compounds or something. So we can get some unique flavors that haven't been tested, but that's definitely based on the library that we have available. And I think later on in this presentation, when Francisco talks about the generative AI for flavors and fragrances, this will be more in that realm, so which is exciting to talk about. And yes, thinking of Willy Wonka, I do feel like Willy Wonka in the lab, and I think my friends outside of the company kind of assume that, especially when I'm working on like confectionery applications.
Yeah, and well, using synthesis though, the range of flavors that you get is really dependent on the hypothesis space you create. So synthesis will look for different combinations of only the ingredients that you set and within the ranges that you configure. So while you will get novel flavors, it will be within a specific range that's defined by the hypothesis space.
Okay, so after that slide, once we repeated for the 5 batches, as you can see, by the 4th batch, we achieved a trial score of 0.7, which is considered the action standard, with 1 representing a perfect match to the target, no differences, it's like perfect. And as you can see by the 5th patch, it didn't perform as well. And this is due to a strategy focusing on exploring more formulations rather than exploiting more formulations that are successful, and which doesn't always lead to immediate improvements. So synthesis can generate two batch formulation routes, and one being the exploitative route leverages information from previous trials that were known to get a high score. And then it can generate more exploratory batches, which tries new combinations to learn more about interactions within this hypothesis space. So, however, even though this seems like it would go against the trial score, what we're aiming for, it is really important for exploration, and it's crucial for advancing the technology, getting a deeper understanding of ingredient relationships and sensory profiles within this really flexible hypothesis space.
Awesome. Thank you, Cindy, for walking us through that. So this was really a pivotal moment for us. Flavor is one of the key drivers of success of a product in the market. So it was also something that we typically didn't have a lot of influence in. We rely on flavor houses to create the flavorings, which are combinations of volatile ingredients that create a sense of this particular scent. And while working with them, we always ran into trouble. Our food matrices are really unique because of the plant-based building blocks. And the flavor house would send us an off-the-shelf flavoring, which really wouldn't work at first. So we had a really long and painful back and forth with the flavor house to really nail it down. So to be able to use synthesis to get to a better flavor in our food matrix was really, really a really important moment for us. Fernando asks if Giuseppe will be available for companies outside. And yeah, this is something that we're exploring right now. So Formulate OS and synthesis we're looking into selling them as a SaaS product to other companies. Yeah. Doing this this exercise of using synthesis to create products. I'm sorry about the list, but synthesis is kind of hard to say. We were working with a flavor house partner in Chile called Kramer. They have over 80 years of experience in the Latin American market. And we saw that this method, while we could get to really good results really quickly, it had its downsides. As you can see, creating the hypothesis space and creating your restrictions is something that's requires a lot of technical knowledge. It's pretty involved, and the iterations with an external partner can be sometimes difficult to manage, create a good schedule. So we saw that newer AI models could give us an edge, and they had a really good data set for flavorings and fragrances. So from the AI modeling standpoint, working with fragrances and flavors is pretty much identical, and they had a more robust data set for fragrances. So we saw an opportunity there and partnered up. They could give us access to tens of thousands of fragrance formulations, and we trained this next generation machine learning models for working with fragrances. So this is what I'll be talking about now. So as far as we know, we built the world's first foundational model for fragrance. So this is a model that can take in a natural language prompt, and it creates the entire fragrance formulation for you. So all the different volatile ingredients and their concentrations. And it will smell like what you're describing. So it's not a fine-tuned GPT. Like when you hear generative AI model, you typically associate it with these types of models. Those treat all your data as text. So this is a custom-built transformer architecture that creates an internal understanding of the different raw material ingredients and how they interact in a way that really wasn't possible before with other types of architectures. So it's trained on this vast historical fragrance data set, and it uses the molecular structure of volatile molecules to generate these formulations. And having complete control over the architecture allows us to define different variants of the model and do a fine-tuning step to solve other downstream tasks that are important for fragrance scientists. And this gives us better performance than building a model from scratch to solve this downstream task. For example, there's an attribute of these formulations called a flashpoint that relates to its flammability. So this is really important to know for fragrance scientists. So the fine-tuned version of our model performs better than a model custom built for flashpoint prediction, which is really cool. So as I said, just like other GenAI models, this GAT is what we're calling it, Generative Aroma Transformer. It's a name marketing hates, but one that really makes sense in terms of the AI involved. It takes in a user prompt as natural language, and it will generate an entire fragrance for you. And what's cool about using natural language is that we can go beyond the lexicon that fragrance houses use to describe fragrances and try things like, I want the smell of Christmas. And there the model generated a fragrance that smelled of cinnamon, cardamom, cloves, which are what you typically associate to that. So that was really interesting to see. Maybe you can take a couple questions. I saw that they were popping up.
I can ask. So Fernando asks, does Giuseppe replace or enhance a chromatograph? I think I'm pronouncing that right.
Yeah. So the chromatograph, you can take in a sample and get the volatile profile of that specific sample. So all the different volatiles and the concentrations therein. So it's a way to measure or take a photograph of the smell. So what we can do with this model is, for example, take the chromatograph of your food matrix, see all the different volatiles that are there, and then use the transformer to add to that profile in a way that it creates the scent you're looking for, flavor you're looking for. So say you have a protein food matrix for a plant-based patty. So you know the sensorial attributes for the patty. It has to be meaty, beefy, all these different attributes. So this model can take into account the volatiles that are in the food matrix and the description of the odor that you're looking for, and add just the right number of volatiles so that it creates something that works with the food matrix. So that's really exciting. Also, we typically use chromatographs to look at a target. So we wanted to create the taste of, I don't know, Kirkland patties. So we would use a chromatograph to see what volatiles are in that patty, and then try to create a flavor that mimicked that entire profile. So this allows us to get out of that workflow, and it allows flavor scientists to define in sensorial language and natural language the aroma they really want. So they don't have to restrict themselves to copying a specific target.
Serge Patel has a question. He says, are there any academic papers on your research, anything proprietary not proprietary that you can share?
Yeah, we're working on a patent for the model. So I can share that when it's approved.
So this is the closest you're going to get, folks, the research you guys are presenting. So And we can get to the rest of the questions at the end of the presentation, so you guys can keep going.
So going back to that slide on creating scrappy software and scrappy models, this is a look at the first version of an interface for the model. And as you can see that there are different inputs. So you can define your application, olfactory family, subfamily. This was a GIF, but you can imagine the system generating different formulations in seconds in parallel, which is really cool. And to get back to the point on modeling complex volatile interactions, this is an example I always use, but in red wine, you'll find isoamyl acetate and whiskey lactone, which are two volatiles that explain the smell of red wine. Isoamyl acetate has a predominantly fruity and berry smell to it. And whiskey lactone, on the other hand, has a completely different profile. It smells like wood. So the thing is, these two molecules interact with each other and with your chemoreceptors in a way that if you have isoamyl acetate and you add a small concentration of whiskey lactone, it will boost the fruity notes of the isoamyl acetate. But if you add a large concentration of the whiskey lactone, it will suppress all the berry smell. You will barely perceive it. So this is just to say that when you add different ingredients to your fragrance formulation, it can really mess things up. It can unbalance the different sensorial notes that you want. So a naive approach, let's say you have furfural and isoamyl acetate already in your formulation, and you want to make it more fruity. The naive approach would be to go into your raw material list and look for something that look for another volatile that has a fruity smell. You would take it, add it to your formulation, but because of these complex interactions between the volatiles, it could completely mess up the balance or completely mess up the smell. However, this model, by having looked at thousands and thousands of fragrance formulations and the sensorial attributes, it can understand that if it had already added isoamyl acetate and the user prompt asks for really fruity smell, it can add a small quantity of whiskey lactone, which has a completely different profile, but it can boost the fruitiness by interacting with the volatiles that are already there. So this is something that flavorists take years to develop this domain knowledge. There are only like 600 certified perfumists in the world. They require 7 years of training, and this model can understand it just by being trained on this large data set. And yeah, I also mentioned that we also leverage the atomic structure of volatiles. And this is a previous model that we had built, a GNN model that can create embeddings for the different molecules by looking at the atomic structure. And we can pass that to our transformer decoder layers so that it also knows the structure of the volatiles, and this additional information makes the model perform better. So what do I mean by this? So every molecule, you can represent it as a graph, where each node in the graph is a different atom, and you create you add a little number depending on the type of atom it is, and then you create an adjacency matrix that tells you what atoms are bonded with each other in the molecule. And you can also characterize the different types of bond, if it's a single, double, or triple bond. And then we use a GNN, or a graph neural network, which is a machine learning model that can take in the numerical representation of the graph structure, and it will create a single numerical vector that represents the structure of the entire molecule. And the neat thing about the network is that once it is trained, it produces similar vectors only if the graph structure of two volatiles are similar. So this numerical representation is something that we can give the transformer model to enhance its performance. So those are all the technical details, but what did we actually do in the lab? We did a validation where we took a bunch of formulations in their historical database, and we had them on the shelf. So those were ready to go. But then we saw the sensorial description of those formulations in the data set and passed it directly to the transformer model to create an alternative formulation to fit that description. So the generated formulations were ready in under a minute, and we didn't do any modifications from a perfumist. And then we went to we did a blind panel with the partners perfumists, and for each of the different cases, we showed them the two formulations. So they saw the sensorial description. So this is what it's supposed to smell like. And then they smelled two different formulations. Both of them had to match that sensorial description. And we asked them, which one do you prefer? And we saw that in 50% of the cases, their perfumist preferred the AI generated one to the one that they had on the shelf. So the model was performing on par with their perfumists, which was a really amazing moment for us. We really didn't expect that level of performance. We wanted to see how far behind we were. And at first, their perfumists were kind of sensitive about it. They started saying that, oh, but the AI generated formulations were unbalanced, or these more ethereal ways to describe the formulation. But after talking it through, seeing what their experience was, they got really excited because this can give them a starting point that's different to the things that they're used to, and it can really unlock their creativity. They can focus on creating and have the grunt work done by the AI, which was cool. And since that validation study, we have been working with different brands to get these fragrances to market. The one I'm most excited about now is we're working with a clothing brand in Latam to bring custom fragrances, so a fragrance built from scratch, to market. And we're looking at building those 10 times faster than traditional development. So to build a custom fragrance, a fragrance house typically takes about 6 weeks to develop a new fragrance. And we're going to be doing 5 custom fragrances in 3 weeks, which is a 10x improvement. So if it works, fingers crossed, it will be a really, really cool milestone. We should know next week how we go.
So I'm happy that Francisco got to break all down. Really cool new tech, and I wanted to go over some typical flavor scientist workflow of working with a client, and kind of some pain points within that, and how the GenAI can really help with that process in the future. So recently we had a client that asked for a novel flavor that would be known to perform well with customers, and they wanted it to be unique. And there was no marketing direction given or kind of that fruit flavor that they were looking for. So this was a major challenge to craft this flavor due to trying to turn concepts in natural language into flavorist language. So that was a lot of digging for me to try and think of starting points, but we made do and created several formulations for our client to try. And when we sent these formulations, it took a few weeks to months to get to a good point. And within this time, this feedback was still very vague. and confusing. And a lot of it was like, oh, we really like this flavor, keep going with this one, or we really don't like this one, we don't know why, but don't do this. And there was a lot of something like tutti frutti. We want it to be more tutti frutti. There's so many fruit flavors that comprise tutti frutti. So not knowing which direction of tutti frutti to go with. And this led to needing a lot of domain knowledge to try to figure out the best direction. And at the end of this, our client was very happy. It just takes a lot of time. And can you go to the next slide, please? And so this typical workflow between clients and product developers, flavorists, lead to a lot of communication pain points. And a lot of this is due to just language translations. And this also leads to stretching out development time through getting that feedback back and trying to go from there. And this is also there's a lot of resource drains with this in trying to create these formulas, product developers implementing them into a matrix, and the sensory feedback. So within this, GenAI can really help with flavor development by translating consumer preferences directly into actionable insights for flavors. As Francisco mentioned, it leverages successful starting points using the flavorist or perfumist library, and it also incorporates alternative or complementary ingredients that can really enhance or refine a flavor or fragrance profile. And the AI can also help fast track product development by finding the most promising formulations quickly. So, as Francisco also mentioned, these formulas can be generated in seconds or minutes and given directly to the flavorist to add any modifications or add a lot of flavorists and perfumers like a signature touch to what they create. And this entire process that has taken weeks to months with client feedback can now be done on site within just a few days, where the client can directly smell them at that time. And as a flavor scientist, it's really important to mention that AI is not just a tool for innovation, it's really a powerful ally for flavorists and perfumers. And by integrating AI into my workflow, I can streamline complex tasks, analyze vast data sets, and uncover new flavor formulations using more out of the box ingredients. And this technology really empowers me to focus on creativity and exploration, while AI does all the heavy lifting of data analysis and prediction. And we want to thank you for listening, and we're really happy to answer any questions.
That was great. Thank you so much, man. It's a 600 flavor scientists. I just doing the math. There's less flavor scientists in the world than like there are NFL players. Like it's like that's an elite. That's like an elite job. It's interesting to me
Yeah.
that they were initially kind of taken aback. The people you're working with, like, oh, so. And I your last slide there really kind of was powerful. I think like this is an ally, a tool to help them get better. Do you think that flavors at large will embrace this, or do you think there'll be kind of a lot of pushback based on your experience?
I think we just presented at FlavorCon a week or so ago, and this is kind of testing the waters with that. And I think a lot of flavor houses, like younger flavor chemists, and are very excited about this. And I think some of the older flavor chemists were hesitant, but really Francisco did a great job of breaking it down because they have so much domain knowledge and experience that they have a lot of data that can be used for those like starting points. And it just makes it so much easier. And they already have so many projects to be working on that I think it can be really helpful to them. And so we already have a couple flavor houses interested in this technology that we're trying to work with.
That's great.
Also, I've learned that there are like in fragrance, there are two large schools, like the French school, and then there's the American school. And the Americans are much more tech focused, making fragrances faster, matching them to the market. And then the French school is more the artistry, the human touches. They call themselves composers of fragrances. So I think it will be a harder job convincing that crowd. But we've seen through these exercises with making actual fragrances for the market, that when the perfumist interacts with the model, it really unlocks a creativity, like a light bulb turns on. They can tweak the sensorial description and see what comes out immediately instead of having to go into the lab and take hours building these fragrances they had in their head. They can see where each descriptor takes them, and they can modify it and see what comes out. And it's like iterating on a simulation really, really fast.
There's a couple of questions I want to get to from Serge and Carlos, but you guys did mention your B2B business started a year ago, and then you guys are looking at turning some of your AI products into SaaS, software as a service, that I think would be generally approachable. And I don't know if you guys could talk to that. I mean, that's maybe more for Adit and like the product people, but are there any details you could give on that? Will at some point I be able to go to like NotCo and sign up for the SaaS and then start using it to kind of experiment with flavors, or is that more going to be kind of partners you do joint partnerships with?
Yeah, so the SaaS strategy got started because we had a lot of interest from the B2B clients to integrate the tech directly into their process instead of having to go through us for every different project. So it made much more sense for them, for their users to interact directly with the AI. So we started building the SaaS offering, which today is limited to Formulate OS, the synthesis, and Concept Quant is starting to get there, but still have a lot to build out. But yeah, the landing pages are due to be published this or next week, and yeah, you can sign up, have a demo with us, and yeah, try it out for yourself.
Serge Patel asks, how does this impact the flavor and fragrance giants like Firmenich in this space? Is this, do you think ultimately this is disruptive, or do you think they'll embrace these types of tools? They'll have to develop their own?
Well, both. So they are trying to develop their own suite of tools. I know that all the large flavor houses have data science departments, and they're trying to create different tools. But from what I've seen, they don't have a model as advanced as we do. And yeah, using a model like ours, you can boost the number of formulations you can put out 10 times faster. You can do with maybe 10 times less flavorists to create custom fragrances. So it can give smaller flavor houses a competing edge towards these large fragrance houses, which the large ones, the top 4 represent more than 50% of the market. So it's really, really hard to compete with them right now.
Yeah, I would imagine that they're going to have to create these types of tools, because if their customers are asking for them, if flavorists see the power of it, and you don't have that, that's a huge competitive advantage for companies that do. So Serge asked, how does the customer synthesize the desired scent? Do you offer the process with the molecule? Do you guys understand that question?
Which one?
How can a customer synthesize the desired scent? Do you offer a process with the molecule? Maybe Serge has to clarify on that. Or do you
yeah. So the model creates the raw material list and the concentrations.
Okay.
And then mixing them is basically liquid handling. There's a lot of detail into how to create the different raw materials, how to store them, which carrier you have to use. But once you have that all set up, it's basically liquid handling. Correct me if I'm wrong, Cindy.
That sounds about right.
Carlos is asking about, I think, some interesting end use applications. So we're talking a lot about flavor houses, for example, but I would imagine this ability to take text prompts and kind of just general descriptions and rapidly turn it into formulas. You just start to think about interesting applications. Like he talks about smell vision. I mean, the media industry has for a long time been trying to add another dimension of sensory beyond just audio and video. And smell has been one of those. I think AI could potentially unlock this. Do you think that could be a potential application? The idea of unlocking, a movie house, looking and showing a movie, putting it into getting data from that, putting it in, and then ultimately creating like a smell type of experience in theater or maybe at home.
Yeah, it's difficult, the smell-o-vision. There's two levels to it. One is capture, and then the other is reproduction. So capture is difficult. You need GCMS machine that require that those usually go for a little about $1 million each, and you need a food scientist to be able to operate it. So really unfeasible. And then the reproduction, you have to mix the different volatiles, and sometimes these volatiles can be very, very expensive. So a model like this can really help with the capture side of it. You wouldn't have to measure a smell in order to create a formulation for the smell. So it solves half the problem. But then the reproducibility is really hard.
Yeah.
I know that there are these like soda machines that you have different cartridges of different flavors, and you can mix those, but it's limited to a few ingredients. Whereas
the
flavor house has
we don't have the freestyle. The freestyle for smell isn't a reality yet.
Yeah, so not yet.
Ryan Kim asks, can the flavor model and the fragrance model work together for food formulations?
Yeah. So as I mentioned, flavor and fragrance, the formulations are really, really similar. It's just that when you create flavor, you use different ingredients, like FDA approved ones, and some really expensive ones you really only use in fragrance because it adds, the specific touch you want. But from the AI standpoint, you can do first a general training on the combined data set and then fine tune for one use case or the other. And that way you can get better formulations.
We have time for one or two more questions. Fernando asks, the AI doesn't mix it up. It just gives the recipe, right? So it's essentially not mixing and matching. It's basically creating the recipe or the formulation. And then it ultimately has to be created by, machines or people in a lab.
Yeah. Liquid handling machines or lab technicians typically.
Could you ultimately automate that if like the AI is powering the formulations, and then I imagine some level of automation? I mean, we're actually talking about like the freestyle for smells and fragrances and flavors. I mean, at some point, does this ultimately get automated in terms of creating it, or do you always have a flavorist or something kind of following the recipe and creating the flavors or the fragrances?
For flavors and fragrances, I really do see a big opportunity in automation. The machines have a lot of benefits to them. They can handle much smaller quantities than a human can, but doing the liquid handling. So you can create much smaller samples and do a more efficient use of your raw materials. So if the workflow is going to be, we're going to create 10 different alternatives for the client to try in that same session, then you would want to formulate smaller batches because you're just trying it out. So that would be really, really cool. And the throughput of the machine can sometimes be higher than the one that a lab technician can have. But the technology is expensive, so it's still an economic problem, right?
I always forget I can actually show these questions, and I realize this at the end of the presentation most, but Vidu asks, he doesn't know if this has been answered. I don't think it has, but he'd like to know, as a food technologist, do you name a flavor, or what are the chances that different companies generate the same recipe? Do you guys understand that question?
Yeah. There's a lot of secrecy in this industry. Sometimes flavor houses will add a specific molecule that doesn't add to the flavor or fragrance, but if you run it through a GC machine, you will pick it up. So if someone else comes out with a formulation for that same sensorial profile, and they see that they added this molecule, they will know they replicated it and that they ran their flavor through the GC mass machine. So when you purchase a flavor, you're not allowed to run it through GC. So these are sorts of things you can pick up on.
Well, this has been fantastic. You guys really surpassed my expectations both times I hear you. I mean, I really enjoy listening to your research, and I think this really is like a peek into the future for people who are involved in the flavor and fragrance world. Just this type of tool set to help you move faster, to help you do your job as an expert, because it is such an elite. It's such an elite profession to be 7 years to train to be a flavorist and fragrance specialist, to use these tools and to be better at it. I just think that this is the direction of the future. So I thank you guys again. You guys have your emails up here. If people want to reach out to you and ask more questions or connect with you, is that okay?
Yeah, that's great. You can also add us on LinkedIn too if you want to shoot a direct message. But yeah, please feel free to reach out to our emails as well.
That's great. All right. Well, everyone, thank you so much for joining us. This presentation will be available in archive on the Spoon YouTube, as well as the Future Food Institute, who's our partner for this Food AI Collab, there on their YouTube as well. And we'll talk to you guys all very soon. Cindy and Francisco, stay on. Bye, everyone. We'll talk to you soon.
Yeah.